Hey, George. Okay, can you see me? So, now,
Yeah, I can hear you.
yeah, okay. So your mom already said your textbook to me. So I'm wondering where have you learned? Which chapter you are learning?
I'm not sure about the textbook chapter, but we just took a test today about um, functions and domain of and we did compositions of functions and
Okay.
bounded and not bounded and discontinuity and stuff like that.
Oh, okay. So how you did?
I think I got a 92. I missed one question, but
Uh,
I'm not sure what I missed.
so do you have that missed question?
No.
No.
She usually there's a certain time that she'll show us.
Oh.
She'll post what we missed or something.
Oh, okay, okay. So now let me give you a question. Can you see my screen?
Um,
No, let's. You cannot see my screen.
no, I
No.
can't.
Okay. So okay, now let me share my screen. Okay. Now you can
Okay,
see
I
my
can see.
screen, right?
Yeah, yeah.
Okay. Now let me open book. Let's see here. So let's see. So what you learn should be here. Something like this. Okay. Now let me make
Yeah.
this one bigger. See, this one's function.
Yeah.
Okay. So now let me try this problem. So can you read this problem? 16.1.
State whether each of the following describes a function or not. For each that is a function, describe the domain and range. Okay.
A. Read A.
Input, name of a month. Output, number of days in that month in 2005.
Is this a
Should I
function?
answer it? Or,
Do you think is this a function?
um, I don't think so.
Why? Can you explain why?
Because the number of days is one specific number. Wait, actually, I think it is. Never mind.
Yeah, actually, this is a function. Let me explain.
Yeah, okay.
What is a function. See, function actually give you a corresponding relationship between two variables. Okay, maybe later you have more variables, but here we just talk about the two variables. One is the input, another is output. So then, if you have suppose I use I to represent input, right? I use O to represent output. Now, if you have the input like this one, so I1, I2, I3, then you have output, suppose this one's O1, O2, O3. See, For this one, like this one, 04, if you have for any input, you have only one output corresponding to that input, then this will be a function. You can also now, we also allow, say, I1 and I2 responded to the same output, O1. And I3 is supposed to respond to this. This one actually is also a function. So a function, if you draw a graph of function, so you just need to check like this. So for this case, this is a discrete function. So now suppose this one it's January. I use J to represent January, then February, then March, then January maybe you have here suppose that's 31 days. 31 days. February you have like 28 days. Suppose here's 28. Then March you have like 30 days. Then the key point is when you draw a vertical line. Whenever you draw a vertical line, suppose here, you draw a vertical line. Maybe I need to move this one a little bit. When you draw a vertical line, then you only get the this vertical line intersect with y coordinate. You only has one y intersection point corresponding to this x, this input, this x coordinate. Then this one will be a function. So now let me give you suppose you have a circle like this. Then when you draw a vertical line, then you have two intersection point, right?
Yeah.
So now say,
So it's not a function.
yeah, see this one is y1, this one is y2. For same x coordinate, you have two y coordinate respond to this x coordinate. This one is not a function, right? But
Yeah.
we allow, suppose, we allow if you draw a horizontal line. When you draw a horizontal line, suppose we have a function is like this. When you draw a horizontal line, you have more than one intersection with this graph. This one is fine. This one is still a function. But when you draw a vertical line, if you have more than one intersection point with this graph, that means that graph is not a function. Okay, if you have one intersection point, that's fine. You have no intersection, that's also fine. Okay, so now let's say this one, name of the month from the January to December, output that's number of days. So for each month, definitely you have one specific of days. You cannot get that January have two output number of days to respond. So this one is a function. Okay, can you check? Can you read B?
Input a positive integer. Output name of a month with a number of days equal to the input.
So input is a positive integer, right? Output the name of the month with the number of days equal to that input.
Would that be no?
So
Not a
why?
function.
Why?
Because like a positive integer, like let's say 30, there's more than 1 month with 30 days. So like if you graphed it, it would have like more than one intersection.
Exactly. You're right. This one, that's not function. Because when you draw a vertical line, at like number input 30, then you have more than one intersection, y intersection point, right? Because more than 1 month has the same 30 days, right? So then this one is not function. So C, can you read this C?
Input a positive integer. Output a perfect square that's less than the input. Wait. I think it's also not a function.
Why?
Because if you have like let's say 64, there's like more than one perfect square that's less than
Yes,
64.
you're right. Now let's suppose you give us 64. Suppose this input number is 64. Then we can find 16. 16 is less than 64. It's a perfect square, less than 64. Then another 9, right? Also 4 and also 1. So then we have 4 output respond to this 64. So then you can imagine geometrically, if when you draw a vertical line at 64 x coordinate, then you have at least this 4 y intersection point. So then that means this one is not function. So then can you read D?
Input an integer. Output the largest perfect square that's less than the input. This one would be a function, I think.
Yeah, this one is a function. Because say like what do you give 64? Then here they don't allow you appear like less than say 49. 49 is perfect square, right? So this they ask you the largest number, but less than this number, right?
Yeah.
So then the only output respond for this input that's equals 49. You cannot set 16 and 9 and 4 and 1. These four numbers is not satisfy this requirement because they are less than 49. Okay, so this one is a function. So then now let's see. When you say it's a function, then they ask you to describe what is the domain, what is the range of this function. Okay, now let's say A. You already told this one it's a function. So what's domain? What is the range of this function?
Domain is 1 to 12.
Name of a month. So domain should be like this. January. You need to write down this January, then February, then blah blah to December. You need to write like this. This is the domain. December. This is the domain. The range, usually we use R to represent. The range is what?
28, 30, 31.
Yes, 3 numbers, 28, 30, 31. Okay, this year is not leap year. If it's leap year, February will have 29 days. That will be, this one will be 29. But for this one, that's like this. Now let's say D. You said D is a function, right? What is the domain of this function? What is domain for this function?
Is it all real numbers?
No, see they give it an integer. So that means domain it's all integers. Integer you can in math you can use z to represent integer set, right?
Okay.
So use use z to represent integers.
Okay.
So what is the range of this function?
0 to infinity.
Actually, no. This is still integer. Say, suppose this one you can use y. This y is still from the integer, but this this y square, square root of y, also should be an integer because this is the perfect square, right? So the square root, you need to require the square root of y also belong to an integer.
Oh, okay.
Yeah. They cannot take like the fractions or the other irrational numbers. They can only be perfect square numbers. Okay. So now let's see. Okay. Number 2. Can you read this part?
Consider the function f of x equals 2x plus 5. Find f of 1, f of negative 3, and f of 0.5.
Can you find f1?
Huh?
f1 equals what?
7.
Yes. F negative 3?
Negative 1.
Okay. F 0.5?
6.
Okay. Then B.
For what value of x does f of x equal negative 3? So that would be... Wait. Is it 1?
Negative 1. They ask you for what value of x. They ask you solve x.
Yeah.
If fx equals negative 3.
Negative 4?
Yes. Then, so that means you need to solve this one equals negative 3, both sides minus 5, you got 2x equals negative 8. Then both sides divided by 2, you got x equals negative 4. Okay, C.
In terms of k, what is f of 2k? Wait. Does that mean like multiply by 2?
Yeah, so then you need to use 2k to replace x. Then think what do you get? You do this. f2k, just compare with this function x equals 2k. So 2 times 2k, then plus 5.
Okay.
So this one will give you 4k plus 5. This one's answer. Okay, now let's try number 3. Can you read this function? Read this one.
Consider the function f of x equals 2x squared minus 5. Find f of 1, f of 5, and f of negative 3. B. Will all real values of x produce a value of f of x? What is the domain of this function? C. Is there a real value of x such that f of x equals 3? D. Is there a real value of x such that f of x equals negative 10? E. What is the range of f?
So let's do it one by one. A.
Okay. Okay. Find f1, f of 5, f of negative 3. F of 1 is negative 3.
Yes.
F of 5 is 45.
Yes. F
And
negative 3.
is 13.
Yes. Very good. Then go to B.
Okay. I think it will.
Yeah, that's true. All real number of x will produce a value of fx. Yes.
And
Then
the domain is all real numbers.
yes.
All real values.
Yes, that's correct. Then C.
Okay. 3. 2 or negative 2.
Yes, very good. D.
No, because a square can't equal negative.
Right, very good. E. Can you write on my screen what is this range? You can use your mouth right on my screen.
Okay. Okay. Wait. Okay. Sorry, I don't have a mouse.
Oh, you don't have a mouth.
Yeah, it ran out of battery.
Oh, so okay. So what computer you're using? Use a laptop or
Yeah, laptop.
use a laptop. Don't have mouth. Okay.
Wait, I have like a stylus. I think.
Yeah. So then you can use that style.
Okay. Okay, I found it. Wait. Oh. Hold on. Like that.
Yes. Very good. Very good. Another way, can you use an interval
Yeah.
format to represent?
That.
Yes, very good. This is correct. Very good. Now let's go to next one. Can you read this problem?
Consider the function f of x equals 2x minus 3 over x plus 5. Okay, find f of 1, f of 1/3, and f of negative 3.
F1 equals what?
Negative 1 over 6.
Yes, correct. F1/3. You can draw on my screen, show how you calculate this. You can write on my screen. Okay, very good. Then continue.
That equals negative. Wait. Over 16.
Yes, your answer is correct. Very good. But here, see, this one is a division of two fractions, right? So the shortcut, you need to change this one to multiplication, but switch the this second fraction as this one it's equals 3 over 16, right? Right, like this. Negative 7 over 3 times 3 over change multiplication division to multiplication, then cancel out this common factor. Then you got this one equals negative 7 over 16. Yeah, don't multiply together. Multiply together, then make the number bigger and bigger. It's harder to deal with.
Right.
Okay, very good. Now let's go to B. Can you read B?
Are there any values of x that do not produce a value for f of x? What is the domain of f? Okay. So negative 5.
Right.
Because the
Yes.
denominator can't equal 0.
Right. Then what's the domain of this
The
function?
domain is. Do I write it? Or
Yeah,
just say
right on my screen.
Okay. Wait. Wait. No. That.
Okay, this one, if you write this one, you need say this one, or you probably need to add or. And usually, say for this case, you just need to write this. D represent domain, okay? D equals, you can write this one, x not equals negative 5.
Okay.
Just like this. If, suppose they maybe allow the x can be complex number, then you can write this x belong to real number and x not equals 5. But usually just write like this, that's good enough.
When do I know to put or instead of and?
Or that means, for set, that means union. Usually this, that means, suppose, actually here you have two sets. One is A, another is B. That's union. If and that means they're to find the intersection like this. So now next, what do you write there? You write x less than negative 5, then x greater than negative 5, like this. So here, people maybe ask, what is the relationship of these two? If you try to find if this one is and, then this one cannot, they have the no intersection point. But if this or this one satisfy or this one satisfy, then that means union.
Wait, could you explain the intersection again?
Intersection, that means suppose we have this one, suppose this one equals 2. This set is OX greater or equals 2. But if I have another set that's like this one is like 4. So this one is x greater or equals 2. This one is x less or equals 4. Then the intersection part of these two set actually is x greater or equals 2 but less or equals 4, right? So that's the intersection point of these two sets. The common, that's the shared or common part of these two sets.
Okay, so would there be like a union part?
The union that's put together. Say what if we said x greater, if we write like this, x greater or equals 2, or x less or equals 4. If you find this one, actually this one will give you this one equals all real numbers. That's cover all the 4 x-axis.
I see.
Yeah. So
Okay, I get it.
now let's say C.
Okay.
Can you read C?
In this part, we find the range of f. Number 1, find x such that f of x equals 3. There a value of x such that f of x equals 2. So, equals 3, okay.
Yeah, you saw. Can you show right on my screen? So this one, they give you the function value equals 3. Then they ask you to find what is x.
Okay. Okay, wait. I think I forgot how to do this.
Oh, both side times the denominator.
Oh, okay.
Then you can make this function, this fraction go away. Then
So, minus, and then times that, so they cancel.
yeah, the right side, yeah, that's cancelled. Then you can get the equation will be much easier than before.
So,
Yes, that's correct. You got x equals negative 18. Very good. Now continue solve. If y value equals 2, what is x?
oh, okay, let me erase this. Okay. So I do the same thing, right?
Yeah, do the same thing.
Okay. I'll just.
Yeah, you don't need to write the x plus 5 to the right side. You can just write right side equals 2x minus 3. Yes. Then you solve x.
And the x's cancel out, so
Right.
there's
no solution, right?
Yeah.
So you got a 10 equals negative 3. That's not possible. So that means x has no solution for x when this function value equals 2, right?
Okay. Yeah.
So then number 2. Can you read 2?
Suppose y equals 2x minus 3 over x plus 5. Solve for x in terms of y. Use the result to find the range of f.
Okay.
Okay. Wait. In terms of y, so like, would I put x as y?
They ask you, say, you use y as input, then find what is the output for x. So that means write x equals something y, like this.
Okay. So, wait.
So then for this one, both sides still times x plus 5, right? Then you merge the term with variable x.
Wait, okay, I started like x equals, and then I do...
No. You need to do this way. Let me show you. You need to do this way. So you start from here. Still y equals 2x minus 3 over x plus 5. You do the same thing. Then both sides times x plus 5. You get a y times x plus 5. This one equals 2x minus 3. Right? Then you expand this. You get x times y plus 5y. Then equals 2x minus 3. Then you both side minus 2x. You get a xy minus 2x. Then plus 5y equals negative 3. So then see these two terms, because variable it's x, you try to solve x. So take x as a common factor. You get a y minus 2, right? Then both sides minus 5y. You can write this one equals negative 5y minus 3. Then both sides divided by y minus 2. You get x equals negative 5y plus 3. See here, then y minus 2. You can also make this one as 5y plus 3 over 2 minus y. Then say that means you times negative to each term of this denominator. You get this one is negative y. This one will be positive 2. So this one is they ask you to find, looking for. So from this, then they ask you determine what is the domain. What is the range? What is the range of this function?
Y is less than...
Y cannot equals 2, right?
Oh, yeah.
Yeah, y cannot equals 2. So the range of this function that say y, then y cannot equals 2. This one is range, right?
Yeah.
Okay, very good. So now let's go to number 5. Can you read number 5?
We can place special restrictions on the domains of functions we define. For example, suppose we have the function g of x equals 3x minus 7, but define the function only for 3 is less than x, which is less than 8. For example, g of 2 is not defined. A. Find x such that 3 of x minus 7 is equal to 0. is your resulting x in the domain of G is 0 in the range of G.
Okay. So first, can you solve 3x minus 7 equals 0? Well, then what is x? Yeah, solve that. Okay, yeah, you get that one equals 7 over 3, right? So then they ask you, is your resulting x in the domain of the G?
No, because it's less than 3.
Yeah, this one is less than 3. Your answer is right. So then they ask you, is 0 in the range of the G?
No. It's also less than 3.
Your answer is now, let's say, is right, but actually you need to calculate. Say the domain is 3 to 8, right? All real numbers from 3 to 8. Then you can plug into this function to find the range of this function. So can you find the range of this function?
Oh. Wait, so I plug 0 in?
No, you not plug 0 in. You need to plug x equals 3 and x equals 8 in. When plug x equals 3, see what you get. Then plug x equals 8, what do you get? Because this function is a linear function, right? So you give the input for x, then you can get the y value. This 2y value should be the boundary of the range.
Okay. So 0 is not.
Right.
Because it's less than 2.
Right. So the range of this function, that's 2 to 17. See, this one is the lower boundary. This one is the upper boundary of the range. So 0 is not in the range of the G. So that's right. Now let's go to 16.6. Can you read this problem?
Functions need not have only one input. A. Suppose f of x and y equals 2xy minus x plus y. What is f of 2 and 3?
Yeah, see this function, they have more than one input, right? They have x as input, also have y as input. Then y here it's input. The output is fxy. Then they ask you what is the value for x equals 2, y equals 3. Can you calculate this?
So that equals plus 3 equals
13. Yes, that's correct. Okay, then go to B. Can you read the B?
Suppose g of a, b, and c equals 2a plus 3b minus 4ac. Find a if g of 3a and 5 equals 15.
Okay. So can you find the A?
Yeah, okay. So g. Wait. Oh, b is a. So
Very good. You're right. Exactly. Yeah. Very good. Now let's see C.
Why is the quadratic formula f of a, b, and c equals negative b plus or minus square root of b squared minus 4ac over 2a not a valid function? Is it because of the plus and minus?
Yes, exactly. You know, here you have, imagine I told you the vertical line. Here you have an input A, B, C. You can think that's for 3D space. That's actually is a point. From that point, respond to the two values for the output. You have a plus, another is minus, right? So then you got two intersection points for output. So that means this one is not a function. Okay, very good. Now let's try do some exercise problem here. Can you read this one?
Consider the function g of x equals 3x minus 4. What is g of 0? For what value of a is g of a equals 0? Okay. Oh, wait. Oh.
Yeah, that's correct. Now, for what value of a is this one equals 0? They ask you find a. For GA equals 0, what is a?
Is it 0?
No. See here, this 0 means output is 0, right? So then you can get equation that's 3, you know, x, that's now is a. 3 times a minus 4, you got this one equals 0. Then you solve this equation, find a.
Okay.
Yes, very good. A equals 4 over 3, make the GA equals 0. Now let's go to second problem. Can you read this one?
Okay, whether each of the following describes a function or not. A. Input. Name of a United States president. Output. Date of birth of that president. So, it is a function.
Yes. This one is a function.
Yeah. Can only have one birthday.
No, that's not because they have the only one birthday. Because they're each president they're not same person. So then think when you draw a vertical line, you know some different president maybe have the same birthday. That's fine. Right?
Oh, I see.
But the key point is all these president is different person.
Okay.
Each president will have, can only have one birthday. Each president can only has one birthday. If we have more than one birthday, that will be a not function. But the different president have the same birthday, that's fine. Okay. Now let's see B.
Input, address of a house. Output, name of a person who lives in the house.
Is this one function?
I don't think so.
Why?
Because there could be like two people have the same name in the same house. Wait,
Not
sense?
accurate.
Oh,
So the correct reason is in a house. Then you maybe have more than one people, right? See, for same address, then you have more than one person respond to that address. So then you can think the address that's you draw a vertical line. Then you have more than one person responded to that address.
oh, okay,
Yeah. So then this one is not a function.
okay,
Now let's see C.
okay. Input a positive integer. Output sum of the digits of the integer. This one is a function.
Yeah.
Because
This one's is a function because for any uh, positive integer, each integer, if they're same, if the integer is same, then their digits definitely will same, right? If the integer is different, their digit may be the different. That's fine. So this one is a function. Okay, good. Now let's see number 3.
Consider the function g of x equals 3. Find g of 2.
This one equals what? Think this. If you draw this function, what is this function? The picture. What's the picture of this function?
A line.
What kind of line?
Horizontal.
Yes, that's a horizontal line passed through the 3. So if you draw a Cartesian line, suppose here it's.
So g of 2 is 3.
Yes. This always equals 3. So whatever, 2 equals 3, 5, this one also equals 3. Then this one negative 100, this one also equals 3. Always equals 3. Because this is the 2, this 2, suppose this one negative 20, 2, 5, then negative 20. This one is x counter. They all respond to the same y counter. It's 3. Okay. So can you calculate g negative 7?
3.
Yes. Very good. Then they ask you, what is the domain of g?
All real numbers.
Yes. Very good. Now, what is the range of g?
Just 3.
Yeah, this domain only has one number. That's 3. This is a range of this function. Only has one number. Okay, now let's go to number 4. Can you read this number 4?
Consider the function f of x equals 2x squared minus 4x plus 9. Evaluate 2 times f of 3 plus 3 times f of negative 3.
Okay, then you can write on my screen how you calculate this.
I don't think it's working. Hold on.
Yeah, this part is right. Then you calculate 3 times negative f of 3 of f of negative 3.
Um, equals 1 0. Wait, hold on. Shoot. Oh. 1 1 7. Is that right?
I got 3 times 39. Yes, that's correct.
Okay. And
Then you add
add
these two together.
30.
Yeah, 147. Yeah, that's correct. Then they ask you, what is the domain of f?
All real numbers?
Yes, for this kind of called polynomial functions, for all the polynomial functions, the domain is all real numbers. Because you did not have the division. You know, if you have division in the denominator, if you have the x, then the denominator cannot be 0. So that will be make the domain is difficult. But see this one, that's all the function domain, it's all real numbers. Now let's see C. What is the smallest possible value of x? What is the smallest possible value of x?
Negative infinity?
No, this one it's a little bit challenge. You need to do this way. You need to take 2 out from the first 2 terms. You gotta this one minus 2x, right? Then plus 9. Then you make this one as a complete perfect square. You write this one as x minus 1, then square. So when you do this, you add 1. You already add 1, so keep this one not changed. You need a minus 1. Then that 1 times 2, you need a minus 2. Then plus 9. So finally, you can write this one as 2 times x minus 1 square, then plus 7, right? So then, can you say this one, what is the smallest value for this function, for this expression? You know, first term, this one, x minus 1 parentheses square, this one always greater or equal 0, right? Should not negative number.
Yeah.
At least the smallest should, for this part, should be 0, right?
Yeah.
Then you plus 7. So then that means the smallest possible value for fx, that's 7.
Oh, okay.
Yeah, this one it's a trick. You need to learn this. Otherwise, for this kind of problem, you don't know what is the smallest number.
I don't think I've ever learned that.
You already learned this, right?
I don't think I have, but I mean, if I did, I probably forgot, but it's not really familiar.
Oh, okay. But you need to know this. You need to know how to do this because in the SAT test or SAT subject test, they always have this kind of problem.
Okay.
And also, this skill has a a lot of very important applications, because if you know this kind of scale, you can solve a lot of problems.
Okay.
So then D, what is the range of F?
Wait, could you scroll up?
Yeah.
Y is greater than or equal to 9.
Double think. Close, but it's not right. See, we already got the smallest value for this function equals what?
7.
Yes, that's the smallest value for fx. Then you should know what is the range of this function. The smallest value for this function, you already know that's 7, right? So that means this function y should greater or equal 7. This one's the range, right?
Yeah.
Yeah.
Okay.
So now let's see. Time is up. I will set you some homework. Okay. I will give you next this one. Let's say number 5, number 6, number 7, number 8. These 4 problems as your homework. How about that?
Okay. Can you send it to me or
Yeah.
somehow?
Can you tap your email on my screen?
Yeah. I'll put it in the chat. I'll type it.
Yeah, you can put it to the chat. That's fine.
Okay.
Okay, let me see. Okay. Okay, I got it. So that's gyfun10@gmail.com. Okay, so I'll send that to you now. Then the next time, before we continue the other stuff, I need to review the homework with you. Okay?
Yeah.
So that means you have to finish the homework. Okay. So we can stop here. See you next. Bye.
All right, thank you.
Bye.